Hello, my name is Anya Carlson, and this is our statistics project on the proportion of M&M colors by flavor, or better well known as the M&M group.
So first and foremost, why did we choose M&Ms? Because our project timeline was really close to Halloween, and we thought, well, let's choose some type of candy or something so that then afterwards we can eat it. So we chose M&Ms, and specifically we were inspired by the fact that we discovered that in 2008, Mars Incorporated, they published the color distribution of the 6 original colors of M&Ms. And so we were curious to see if in our study we could predict what percentage of M&Ms are going to be red, blue, green, etc. in 2022. Historically, Mars releases a color distribution for these 6 colors about every 10 years, and they've done so since 1976. In our study, essentially, what we did is we didn't just look at the original set of M&Ms, but also two other different varieties. One was the original M&Ms, the second one was peanut, and the third one was peanut butter. And these all have the original 6, so we excluded seasonal ones, like such as Christmas or Halloween, that have these other whimsical colors. We just stayed with the original 6 and compared it to the color distribution of 2008 to see if they were statistically significant at a 5% significance level.
This is our methods for our M&M study. We decided that for each variety of M&M we surveyed, we would get a 2-pound bag of M&Ms. This gave us a very large sample size very easily, so that made it extremely convenient. We also decided that since we were counting M&Ms, we had to classify what M&Ms counted and which ones wouldn't, as you would sometimes get broken M&Ms in bags. It's just a fact of production that we had to deal with. And we decided that if we could find an M&M that was 50% there or more, it would be counted. And for each piece of M&M that was less than 50%, those would not be counted. So once we got those bags, we actually counted them. We took the total amount of M&Ms that were in each bag, and thus each variety, and we also counted the individual colors in each variety. And took that information and we calculated the percentage of each color in each variety of M&M. We did find some flaws in the survey method. The first was, this isn't a completely random sample, as we didn't randomize what store we were buying the M&Ms at, nor the time of day or the day itself that we were buying them. I bought the M&Ms at the closest Walmart at a day and time that was convenient for me. We do not believe that this is going to affect our data really at all, since our sample sizes are between 400 and 1200. However, we do think it is of note. Our other bias factor we found while we were searching online and trying to find more information about the M&M color distribution, and that was how the M&Ms are manufactured. Bags are manufactured in either New Jersey or Tennessee. It's a 50-50 chance that they're made at any given one, and each factory has its own claimed color distribution in addition to that overall 2008 claimed color distribution. In this survey, we aren't really looking at the color distribution based on the factory. However, that could have affected the color distributions of the M&Ms we surveyed. And once again, it is noteworthy. If we had realized this before we had surveyed the M&Ms, we would have gotten 2 2-pound bags of each, one from each factory.
After collecting the data and sorting it into graphs, we did a chi-squared test. This required us to convert the expected percentages we got from the Mars Chocolate Company into expected number of M&Ms candies of that color. Once we had the expected amount, we could plug in the observed and the expected values into the formula for the chi-squared test. We can add them all up, which is what the Greek letter sigma stands for. And once we add up all the chi-squared tests together, we have one part of the chi-squared CDF, which will eventually give us the p-value. The other part we have to calculate to perform chi-squared CDF is the degrees of freedom. Degrees of freedom is equal to the columns minus 1. We have 6 colors, aka 6 columns, so 6 minus 1 is 5, and the DF is 5. So now we're ready for the chi-squared CDF in our calculator. So we go to second vars on our calculator, and we go down to chi-squared CDF, not PDF, and we're going to enter 3 numbers. We're going to enter the sum of all the chi-squared tests, comma, if you have an old calculator, infinity, or a number that the calculator thinks is infinity, and then, so we'll put 1,000, and then a comma, and then the degrees of freedom, so 5. Then we'll hit enter, and it gives us the p-value. All right, so now I'm going to explain our results, point out some noteworthy results here. Almost immediately, we notice that the amount of regular blue M&Ms is nearly double the expected percentage. As a result, the regular green, yellow, and red M&Ms were found in smaller percentages. The chi components of these 4 colors were high, so it led us to the conclusion that the percentages were statistically different. And then we calculated the p-value using chi-squared CDF, and it supported this conclusion because it was 0. Therefore, we failed to reject the null, and at least one of the percentages for the regular M&Ms are different. Brown M&Ms of every flavor were found in slightly higher percentages than expected, which has resulted in a similar analysis for the peanut and the peanut butter M&Ms. Other colors that differed from the expected values were green and red in the peanut butter M&M bag. So we did the same evaluation as before, and we noticed that the chi components of the aforementioned color percentages were high, and we come to the conclusion that they are statistically different than the expected values, and the p-value confirms this because it is extremely small and or close to 0.
Our p-values were small enough to provide evidence that the varieties of M&Ms we surveyed did not match the stated color distribution from 2008. Each variety of M&M differs in the way their color distributions vary. Regular M&Ms were much more different from the expected distribution than peanut and peanut butter. We are unable to determine the cause of the difference between the expected and observed color distributions, nor the variability of that difference.
So here is our references and appendix. Here you can find the reported color distribution for different factors, which we found in the middle of our research, as well as the color distribution based on variety, which is the core of the entire study. Thank you for watching our presentation, and we cannot wait to see your comments.